Okay, now, when you're looking at that strip of paper, okay, and you got all these little blocks in here, okay? Now, at the top, you're gonna have a line like that, like this, and like this. It's gonna be at the top, at the bottom, somewhere. There's gonna be these lines right here. They are 3-second lines. Okay, so from here to here is 3 seconds. From here to here is 3 seconds. So them total is 6 seconds. It's important because now let's just say these right here are the QRSs. Okay? So you come up here and you count 1, 2, 3, 4, 5. How many 6 seconds portions are there in a minute strip? There are 10. So 10 times 5 makes your heart rate 50. Okay? That's how you figure out the heart rate. Now, there's another way to figure it out, and we'll do that in a minute. You're going to have to have a piece of paper for that. Okay? This is how you figure out the heart rate. Take how many you count in 6 seconds, multiply it by 10. That will give you the rate. Now, this is kind of going to be a two-part deal of learning the electrical and what the electrical means on a EKG strip. So, first of all, this is your heart. That right there is your SA node. And it is in the upper right atrium. I don't know why I did that. SA node. All right, this is considered the master node. Its normal conduction rate is from 60 to 100 beats per minute. Okay? Now, this SA node, when that impulse travels, when that impulse goes off, okay, that is represented, this is the isometric line, okay, or isoelectric line. Okay? The P wave, which is this right here, all right? If it's coming up, first of all, that means you have a positive deflection. Okay? Now, and we're going to have to put all this together in a minute, so pay close attention. That P wave is a positive deflection off the isoelectric line. Now, that represents when this P wave, this SA node, fires. That represented on the EKG strip as the P wave. Now, it travels down these internodal. Now, these are internodal pathways. Now you may see them called the upper internodal, lateral internodal. You just need to remember they're internodal pathways. Okay? And you got one that comes over here that's called the Bachmann's bundle. And all that does is when this SA node fires and causes this right atrium to contract and force blood into the ventricles, this makes the left atrium contract and force the blood into the left ventricle. Okay? Now these impulses come down to right here. And this is called the AV node, or atrial ventricle node. It is the first fail-safe in the heart. If something happens to the SA node, you get sick sinus syndrome or something like that, the AV node will take over. It fires at a rate of 40 to 60 times per minute. All right? But not only is it a first fail-safe, it is also the gatekeeper. What do I mean by gatekeeper? Okay, you have the tricuspid valve right here between the right atrium and right ventricle, and over here you have the bicuspid. How can you tell the difference, number one, between which is which? And remember you have 3 lobes of the lung on your right side. So on the right side of the heart, between the right atrium and right ventricle, you have a tricuspid valve, 3 leaves, okay? On the left side, your left lung has 2 lobes, so you can remember that this valve here between the left atrium and left ventricle is a bicuspid valve, 2 leaves. It can also be called the mitral valve, okay? So what happens and why this is called the gatekeeper is when the atrium contracts and forces blood down into these ventricles. Okay, this does it at the same time. The atrium contracts, both of them fill with blood. Something has to hold that impulse, okay, long enough for these to fill up with blood, these 2 valves to shut back off before that impulse leads that AV node to go to the ventricles. That's why it's called the gatekeeper, because it holds that impulse, okay, till these valves shut back off. What's important about that, okay? What's so important? Well, this is your P wave, right? There's your QRS. Now, the distance from the beginning of the P wave to where your QRS starts is called the PR interval, which is the amount of time the AV node holds that impulse. Okay? So, this distance from here, beginning of the QRS, beginning of the P wave, should be no more than 0.20 seconds, or 1 big box. Now do you understand why you need to know about this time? Because you're using it to see if this is in the parameters it's supposed to be. If this distance right here between the P wave in the beginning of QRS is greater than this right here, longer than one big block, it's a first degree heart block, which just means this AV node right here is holding the impulse too long. In the EMS, there's nothing you can do for a first degree AV block but look and watch for other blocks to follow. Now, couldn't. All right. Now, we know that this is what causes a first degree heart block, is this AV node is holding the impulse too long. Also, if this fails, the AV node will take over at a rate of 40 to 60 beats per minute. Okay? So we'll talk about this in a minute, but that's important to know about your deflection off the isometrical line, whether it's being positive or negative. Now, when it leaves the AV node, it goes through the only electrical pathway between the atrium and the ventricles. Okay? And it's the bundle of His. Okay? Now it's important to understand that you understand that that's the only electrical pathway between there. Okay? I will teach you later on about some pathways that grow there that's not supposed to, that causes your rhythm to be funky. So that's why I say it. I'm impressed that that's the only natural pathway. Now, when it comes down through here and branches off to your left and right bundle branch, I'm going to abbreviate, I'm running out of heart. Okay? Now, when it does this loop right here, when it reaches this right here, which are the Purkinje fibers, and I may have misspelled it, spelling ain't that my big deal right now. I just want you to know about the heart. I could care less about spelling, okay? And it gets by all this till it gets to the Purkinje fibers on both sides, and this causes the heart to contract up and force the blood out the aorta and out the pulmonary arteries, going to the lungs and going to the body. Okay? If something happens here, these Purkinje fibers will take over and they will fire at a rate of 20 to 40 times per minute. Okay? And this is your last fail-safe, is your Purkinje fibers. Now, a lot of people will tell you that when your Purkinje fibers take over, that since it's coming from the ventricles, it's going to be a wide rhythm, but that's not always true, okay? I'll explain that to you when we get to the heart blocks. Okay. Now, what I need you to understand now is this QRS right here, which is your, let me get this, I'm going to draw it right here. QRS. Okay? This is your P wave. I know I'm drawing it upside down, but it's fun. This is your P wave. Okay? It's your isometrical line. That's your P wave. Now, this is QRS. Okay? That's what it is. QRS. Now, what I need you to understand is the Q wave is the first negative deflection off the isometric line in the QRS. Okay, in this right here, the first negative deflection is the Q wave. The first positive deflection is the R wave, and then your next deflection is the S wave. Okay, that's why it's called QRS. Okay? And then you have the T wave right here, which is the sodium and potassium influxing in and out of the cell again to make the inside of the cell more positive so it can be contracted again. So that's what your T wave represents. Now, what I need for you to understand, when you have just a positive deflection, that's obviously going to be a RS, okay? But just because it don't have a Q wave, it's still called a QRS, okay? It's just got that name, but the first positive deflection off that isometrical line is going to be your R wave. If there is a negative deflection off that isometric line first, then that's going to be a Q wave. Okay, do we have that? Any questions about that? Anybody? Okay, now, when you measure between where your beginning of your QRS, remember I'm going to call this a QRS because that's what it is, even though it don't have a Q wave, which is a good thing. All right, from the beginning of this QRS to where it comes back and makes its final turn on the isometric line, or isoelectric line, excuse me. All right? This notch where it makes its turn like this for the isoelectric line right here is where I'm looking at. Right there you need it to be. And in this corner, that is called J point. Very important to remember a J point. Okay? Because when you're looking at a 12 lead, your J point is right here. It is the beginning of the ST segment. ST. Okay? Which is this portion right in here. That's where you're looking at for elevation for an MI on a 12 lead. That's why J point is so important, because you're going to be looking for elevation at that ST segment, which is between the S and the T wave. ST segment. So you think about stemming. ST elevation MI. Thank you. That's what that stands for, is elevation in the ST segment. That's what STEMI means. NSTEMI just means you don't have no elevation. No ST elevated MI. Okay? So this is what you got to learn about this, all right? Now, when we were talking about the QRS over here, all right, what you're supposed to do between that J point and the beginning of the R wave or Q wave, wherever, the QRS complex. I'm gonna make some room here to write, if y'all don't mind. Huh? Okay, now, what I was telling you about your QRS, okay? just say this is the QRS right here, and you're leaving off the isometric line. This is your P wave. I'm making it a little bit larger so you can see, okay? But from the beginning of your QRS to the end where it goes to the isometric line, and this is your J point, okay? You have to remember that. The distance between here, okay, when you're looking at this block right here, can be no more than 3 little blocks wide. Okay? 3 little blocks wide, that means it cannot be no wider than 0.12 seconds. Okay? 3 small blocks. That's why you have to know about these blocks and the time in between them. Now, if it's wider than that 0.12 seconds, okay, depending on whether you have a P wave present or not, and we'll get into that in a minute, it's taking too long for this impulse to travel through those bundle branches. So you could have what we call a bundle branch block, okay? And the longer it takes those impulses to travel through that bundle of his into that left and right bundle branch determines how wide this will be, okay? So if it's more than 3 blocks wide for your QRS complex, it's taking too long for that impulse to travel through the ventricles of the heart. You have a delay somewhere. And I will get in that in a minute where I'll show you about what's causing the delays. Okay? But right now you understand that your primary pathway is, your primary node of your heart is the SA node, which is the sinoatrial node. Okay? And it is the primary pacemaker of the heart, beats from 60 to 100 beats per minute. Okay? Then you have the internodal pathways and Bachmann's bundle, okay, that causes the atriums to contract. Your AV node right here, when those impulses come down and get to that AV node holds that impulse long enough for these ventricles to fill with blood and to shut these valves back off, your tricuspid and bicuspid or mitral. Then it releases that impulse down the bundle of his to the left and right bundle branches. I know this is right and that's left. To cause the contraction of the ventricle. Do you understand that so far?
Yep.
Okay, cut.